Standard deviation of the sample is S equal to root of summation of I equal to n to xi minus x bar whole square divided by n minus 1. This n minus 1, the degrees of freedom for one sample t test is n minus 1. The degrees of freedom for one sample test t test. One sample t test is degrees of freedom n minus 1. Actually, total n, we are detecting one sample. So remaining sample will calculated here. Okay, degrees of freedom for one sample t test is n minus 1. Okay. So actually here this one, okay, for all the samples we are calculating addition. This one, actually what we are doing, xi minus x bar, x bar always deduct from x1 x2 up to n, then squaring, then for x1 one time, so doing all the up to n, from 1 to n, so squaring, then divided by, this is for reduction 1 from total n. That's why we are mentioning the degrees of freedom for the one sample t test is n minus 1. The degrees of freedom for this is one sample test. One sample t test is n equal to 1. That is, if for example 50 samples, then 49 here. So 49, one sample test is 49 like that. So this is the freedom, degrees of freedom. Okay, then we are going to discuss CI for the one sample t test. The formula to compute a two-tailed confidence interval or the mean for the one sample t test. CI for the one sample t test. The formula to compute two-tailed confidence interval for the mean for the one sample t test. Confidence interval 1 minus alpha. Alpha you have to reduce from 1. Then equal to x bar plus or minus t alpha divide 2 comma tf. T alpha divide by 2df into s by root n. If you want to calculate to one side CI, change the plus or minus sign to either plus or minus, and use the upper critical value and alpha rather than alpha by 2. So total n, you have to take root for the reduction, then we have to then s value divided by this value, then we will get, then you have to multiply with this t alpha divided by 2 comma df, multiply. After that we have to add or subtract x bar subtract from total how much I am getting, or add. We want to calculate one side, that's why we want to one side CI change the plus or sign to either plus or minus. We are using both side and use the upper critical value and alpha rather than alpha by 2. Okay. Two sample t-test independent samples. Two sample t-test independent samples. Okay. The t-test for independent samples. The t-test for independent sample determines whether the means of the population from which the samples were drawn are the same. The subjects we have to note this point here. Independent samples. True sample test independent is the very important. Separate. Okay. The t-test for independent samples determines whether the means of populations from which the samples were drawn are the same. This is the samples. Here, populations from which the samples were are same. Population are same. The two independent samples determines whether the means of here one sample, here one independent. The populations is the same. Okay, determines the whether the means of the populations from which the samples are drawn the same or not. The subjects in the two samples are assumed to be unrelated and independently selected from their populations. We assume that populations are approximately normal distribution or sample large enough to invoke the central limit theorem, and that the populations have approximately equal variance. That the populations have approximately equal variations. Variance. So x1 bar minus x2 bar. X2. This is two sample. No, first sample, second sample. So from second sample, to subtract from here, and then mu1, mu2 also second sample deduct from first one. Then we have to again subtract how much we are getting from this subtract, and then this one. After that, we have to n1, n2, how much n1 in first sample, then how much in second sample, then take among these we take only one, here also only one, then add, then a square p, multiply with this a square p, then we have to reduce this value, no, that's why square root, we get x mu, no, from this we have to divide this value, this much we have this one, so physically, so that P is the test, this t-test for this, where the pooled variance is, for this one. This one a square p is the, no, this is the pooled variance equal to n1 minus n1 s square 1 plus n2 minus 1 s2 2 divided by n1 plus n2 minus 2. See here, n1 from first sample. How much? Then deduct. For 50 example, maybe 49 available. Here also same. Then s square 1. See from here, that one multiply, that one, this one also s2 also here from sample 2, you have to multiply, then add, here to be add, then divided by n1 n2 add, then deduct from 2, deduct from 2, then how much you are getting, then yeah, this value we have to divided by this, then we got a pooled variance. Okay. Okay. CI for the independent sample t-test. CI for the CI for the independent samples t-test. Independent. That one two samples. Here total independent t samples. Okay. Not in one. Okay. Then CI 1 minus alpha. We have to how much we are getting, that alpha to be reduced from or subtract from 1. Okay. CI for this. So x1 minus x2. Independent. We will take two samples. x1 bar first string, x2 bar this one deducted from this. Okay. Minus subtract. Then plus or minus T alpha divided by 2 TF. Okay. Add this. Then that is T alpha this T test alpha divided by 2 means average. Okay, that is divided by 2. Total how much you are getting? Generally we are 2, that one 1 by 2 means half, no, like that we are 50 making 50%. Then s square p pooled variance, then n1 1 by n1 plus 1 by n2, then how much we are getting to be added, then multiply it, then take square root, then multiply it here. Okay. Why square rooting means it is reduction purpose. Okay. Okay. For square purpose, for increasing that value showing, square root means reducing value. Scaling only, that is scale in engineering. Okay. Then repeated measures t-test. Repeated measures t-test. Also known as related sample t-test or dependent samples t-test. The samples are not independent. Also known related sample t-test. Related sample related, this is a related sample t-test are the dependent samples t-test. One dependent sample t-test. The samples are not independent. Okay. Okay. The measurements are considered as pairs. So the two samples must be the same size.